Okay, today we're going to talk about graphing rational functions. Just remember, rational function is any function that can be written as a ratio of two polynomials. Remember, rational means it can be written as a fraction. So rational functions are fraction functions, so they have a denominator. Talking about that, all look a little bit different, but we can call 1 over x a parent function. The vertical asymptote comes from the denominator, so we set that denominator equal to 0. We get x equals 0, so it goes to the x-axis at 0. And then the horizontal asymptote we'll get into, but in this case, it's y equals 0. So remember how I told you all parents use 0, 0, and all parents use right 1, up 1. So this is how this one works. So you can kind of tell what's going on by those values and where those branches cross or are used on the graph. The domain is split because of that vertical asymptote. So since my asymptote is at 0, I use that 0 as the dividing line. So it says this graph is coming from the left at negative infinity, gets as close to 0 as possible, gets closer and closer and closer, never crosses, never touches. Notice that this is going down at this end. So on the other side of the asymptote, it starts opposite. So it starts at the top at the right side of 0 and goes and goes and goes, never touches. Now the horizontal asymptotes are a little bit iffy. You can touch it, you can cross it and then hop back up or below it, depending on where the branches are. So those aren't a hard boundary line. There's some give there, but the verticals you cannot because you can't divide by 0. So range we can talk here, but there again, it may not have a range of that. So we really concentrate on the domain of a rational function. Okay, so some things about rational functions is the domain is all the roots of the denominator. So we'll get into that when we have wholes, and sometimes that piece of the denominator is factored out, but it's still part of the domain, and we'll talk about that when we get to an example. And then our vertical asymptotes are also the roots of the denominator, so my domain and my vertical asymptotes are connected with the same numbers. If I have a hole, I take that vertical asymptote out, and it's still called what is called a discontinuity, but it's not an asymptote. It's like a little blip in the screen. Now, the horizontal asymptotes are a little bit more. It is more of just memorizing what these are. I can have none. I can have one, but I can't have more than one. And it's always based on the degrees of the numerator to denominator. So what I mean by bottom heavy, that means that the denominator has a higher degree, like x over x squared minus 4. This is a degree of 1 over a degree of 2. The bottom is heavy, so that asymptote is always y equals 0. Then I could have an example or a comparison where the top is and the bottom have the same degree. An example of that would be like x over x plus 3 or x minus 1 over x plus 3. They have the same degree, a degree of 1 over a degree of 1. Remember, that's the exponent to the x. So what LC, remember that means leading coefficient over leading coefficient. Remember the understood ones here. So this would be y equals 1 over 1 is 1. If I change these to 2 over 1, then 2 over 1 would be y equals 2. So that's how the same degree works. And then the third and final, because you can't have another example like this, is where the top is heavy. You have no horizontal. This is where you can have none. There is no horizontal, but it might be a slant. So a slant asymptote occurs when the degree of the top is one more than the bottom. So that would be an example like x squared minus 4 over x plus 3. That's a degree of 2 over degree of 1, so it has a slant asymptote. If I have something like x cubed minus 8 over x plus 2, that's 3 over 1. So there's no slant asymptote either. So there's no horizontal, no slant. Then we go on to some other pieces, and keep this in mind in class that if you choose that note card, this is a wonderful thing to put. So x-intercepts are the roots of the numerator. Set all the factors of the numerator equal to 0, solve, and those are where it crosses the x-axis. Then the y-intercept is the constant over constant. So an example of something like that would be if I had x squared over 4 over x squared minus 1. That would be negative 4 over negative 1, which is positive 4. So that would be the y-intercept. And then the last piece, which you don't always have these, you can, is a whole. And it's when I reduce it, common factor in both numerator and denominator, then that gives me a whole. So it's part of that domain of one of the discontinuities where we have to union that piece, but it's not an asymptote. Okay, so when you're graphing, you want to factor the numerator and denominator. You're going to look for holes. And then after that, you're going to determine your vertical asymptotes. Then you're going to find your horizontal asymptote, which you're comparing the degree. And this is where I would do it from the original, not the factored form. You're going to find your x-intercepts, and you're going to find your y-intercept. Okay, we're going to start off with a function that is already factored. I can't factor it, as a matter of fact. So we're going to go through and do this. I always start with my x-intercepts. I always start with my asymptotes. I look at that bottom, and to get my vertical asymptote, it's x plus 1 equals 0. Subtract that 1, so x equals negative 1. That means I have a boundary line. Notice it's dotted, and when you put these in the graph, you don't even see these because they're not graphed. So there's only one. Now I'm going to go and look at my horizontal asymptote, and this is a degree of 1 over degree of 1, so it is the same. So that's leading coefficient over leading coefficient, which is 1 over 1, which is y equals 1, and then that would be that y-intercept. That horizontal asymptote. Now my intercepts come from two different places. So the x-intercept comes from the root of the numerator, which is x plus 4 equals 0. So that is x equals negative 4. So I have a negative 4, 0. And then I go and get the y-intercept. And the y-intercept comes from constant over constant. So on top, that constant is 4. On the bottom, that constant is 1. So the y-intercept is 0, positive 4. So now when I go put on my branches, I know that there's 1 here because I have an x-intercept that puts a branch there. And I have 1 up here, which puts the branch there. Now I want you to know that most of these, as we move along, will be catty-cornered to each other. They're alternating zones divided by the asymptote or asymptotes. Since I have 1 asymptote, I have 2 branches. So this domain would be from negative infinity to that vertical asymptote, which is negative 1, and then -1 to infinity. Okay, this next one, I need to factor it. So those of you that can't factor, make sure you and I talk about it. So I need the factors of 6 that add to 5. That is +2 and +3. So x plus 2, x plus 3. And then the bottom, I need the factors of -2 that combine to +1. That would be x plus 2, x minus 1. So look, there's a hole. X plus 2 over x plus 2 is a hole at -2. Okay? Now what you do to find the y-coordinate is what's left over, which is x plus 3 over x plus 1. I plug in that -2. And so that's 1 over -3. So that's -1/3. That's a weird way I wrote that. So that's -1/3. I put that on at the last when I have my branches on. Okay, so I've got that hole. So now to get the vertical asymptote, I just use the factor that's left. So this is going to be x equals +1. And now I do my comparison. I do that back at the beginning before I factored it. And so it's the same degree of 2 over 2, so 1 over 1, so it's y equals 1. My x-intercept, now since I have a hole and I've crossed those out, that's not an x-intercept on top, like it's not a vertical asymptote on the bottom. So my x-intercept is at, let me do another color, is -3, 0. And then my y-intercept, I go back to the original, which would be that 6 over -2. So 6 divided by -2 is -3. That would be 0, -3. So I know for sure I have a branch here. And of course that pattern tells me the other branch is there. Now I'm going to go back and put that hole in. That hole is at -2, 1/3. And of course, since we're just sketching them, put an open circle to show that that is where the hole is at -2. Okay, the first thing I'm going to do is factor the top and factor the bottom. So my factors are x minus 4, x plus 4, because that's the difference of squares, over x minus 2, x plus 2, also a difference of squares. I don't have any holes, so I'm done. This one will have 2 vertical asymptotes because I have 2 factors on the bottom. So x equals +2, x equals -2. Now I do my comparison. It's the same because it's a square over square. So that would be 1 over 1, so y equals 1. So now notice that I have a zone, a zone, a zone. That's what I call them, which means I'm going to have 3 branches total. So now my intercepts help me determine where these are. My x-intercepts are going to be the roots of the numerator. So I'm at +4, 0, and -4, 0. So I know these branches are here. So the center branch can be at the top or it could go through the middle. So sometimes it depends on where we find our y-intercept, in this case of where it would be. And so my y-intercept would be, remember that comes from the constant over constant. So -16 over -4 is at +4. And of course you can look at your calculator, but because it's right in the middle of the 2 asymptotes, I know it's like a parabola up at the top. When it's off center, then you kind of know it might go through the middle. So we'll talk about that as we practice, but you can always look at your calculator. Okay, this one isn't factored. I'm just going to go through and remember the asymptote comes from the root of the denominator, so that's x equals 3. This is a less over more because it's a degree of 0 over degree of 1, so that's y equals 0. So there are my two asymptotes, which is at x equals 3 and y equals 0. I have no x-intercepts because there's nothing to solve on the top. Also, I have a y-intercept at 0, so unless there's something there, it doesn't dip above or below it. But my y-intercept is from that constant over constant, which is 3 over negative 6. So my y-intercept is 0, negative 2. So this tells me I've got a branch down here and a branch up there. Okay, this one I need to factor the top. It's x squared. I'm sorry, not x squared. It is x. It's a difference of squares, so x plus 2, x minus 2 over x minus 1. There is no whole, so my vertical asymptotes from the root of the denominator, so x equals 1. Then it is a degree of 2 over degree of 1, so it's more over less, and that's a 2 over 1, so this tells me I have a slant asymptote. The way you find a slant asymptote is you divide. The bottom is my divisor. It is a degree of 1. We can do our synthetic division, so 1. The number in front of x squared is 1. The number in front of x is 0. The constant term is 4. Drop down my 1. 1 times 1 is 1. Bring it down. 1 times 1 is 1, negative 3. Remainder, constant x. Remainder doesn't matter. So it's y equals x plus 1. So we start at the y-axis, and we have a slope of positive 1. So I'm going to put that asymptote in by graphing all the points. Okay, so I have that. Now I do have zones. I've got 1, 2, 3, 4. Okay, I still have 4 zones, so we have to determine where it is. So we hope that our intercepts will help us. So the x-intercepts come from the roots of the numerator, so negative 2, 0, and 2, 0. Which is great because it goes every other zone. So I have a branch that comes in here, and I have a branch that comes in here. Okay, last example. So I got a factor top, factor bottom. So the top is a common factor, so I pull out that x and get x plus 3. On the bottom, it's a difference of squares, so it's x plus 3, x minus 3. We see that we have a whole at x plus 3, so my whole is at negative 3. And now I plug in that negative 3 with all the x's left, so it's negative 3 over negative 3 minus 3. So it's negative 3 over negative 6. So that is positive 1/2. So there's where my whole is. So let's go to our asymptotes. Asymptotes are roots of the denominator, so x equals positive 3. The degree is the same. The coefficients are 1 over 1, so it's y equals 1. So positive 3, positive 1. I'm going to go ahead and do the domain because I didn't do that with the last whole. we have to include everything because there's a hole. So this would be negative infinity to negative 3, negative 3 to positive 3, and 3 to infinity, because there is a discontinuity at the hole also. So that is what the domain would be. Now my intercepts, I have roots of the numerator gives me the x-intercept, and so that is the only intercept left would be x equals 0. So I have an x and y intercept at 0, 0, branch, branch, and then we go plug in that hole, which is at negative 3, 1/2, so 1, 2, 3. There's my hole. And there, hopefully, is enough examples to help you graph.